Sum is further square. When we consider sum continuous one, we have a convention for that. If the x0 is a sum continuous point. If 0 sum continuous, discontinuous point. If x0 sum is continuous point, we can denote Zx0. Zx0, it belongs to absolute. The difference between two one-sided bits. Okay, you can denote this by is equal to absolute difference of two one-sided bits. You can denote this by the value Zx0 is called the sum of function of x0. Sum function of x0. Bước nhảy, hàm bước nhảy ở cái điểm không, tức là độ lệch giữa giới hạn trái và giới hạn phải. Độ lệch giữa giới hạn trái và giới hạn phải gọi là hàm nhảy, hay là bước nhảy tại điểm không hàm độ. Okay, now when it comes to this example, what do we think about the sum function at x0 equals 0? What value?
1.
Okay, it has into the difference between absolute value. 1 minus 0 equal to 1. Absolute value of difference. Two sided, two one-sided. Okay? Now we have a different example. We consider the function sin x over x. We take the x0 equals 0. Now tell me the x0 this continuous point of function. This continuous. The function f has the formula f equals sin x over x. What do you think about the x0 equals 0? Continuous or discontinuous point? Discontinuous point. Why? Very easy to see the function here not defined at 0. Okay? Not defined. Okay? The first subcondition. So the x0 equals 0. Discontinuous point of function. Now, continue. We want to know which type of x0. Which types? First, second, third. You can see in the three conditions here, we always check one-sided bit. Always check one-sided bit. Now, we return to the function f equals sin f over x. We want to know one-sided bit of function. When x tends to 0 from the left and from the right, you can see the one-sided bit all the way at 1. 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 It belongs to second definition. Okay, the left and right hand limit is equal and finite. So the point we consider here removable discontinuity. Removable discontinuity. Removable discontinuity. Removable is that mean the function here, it may be we can add the value function f at f0. It may be we can derive the function here by default fx is equal sin f of f. F is not 0. If f equals 1, if f equals 0. If we derive function here, you can see the function over f here continuous. Well defined as x0 continuous. So this point x0 equals 0 here has the name removable discontinuity. Okay? Exactly, we can at the value function f at x0, the function is become a continuous function. So x0 has the name removable discontinuity. Tức là đây là cái điểm removable discontinuity, exactly là tức là chúng ta có thể thêm một cái điểm nữa vào và cái hàm số mới có thành hàm liên tục, thêm một cái và hàm thành hàm liên tục. Thì cái điểm đó người ta gọi là điểm giáp lắm có thể bỏ được. Đấy lý do tại sao nó gọi là điểm giáp có thể bỏ được. Thêm một điểm thôi và hàm thành liên tục. Okay. Now, we consider the function fx equal exponent 1 over f. 1 over f. We consider the x0 equals 0. What do you think about the x0 equals 0? This is continuous point or not? Why? This continuous? Yes, why? We need the formula of function. If the function here is not defined at x equals 0. Okay? Not defined. Not defined is that means x0 here, this continuous point. This continuous point. To continue, you want to check the x0 belong to others. Now, we return to definition related to discontinuity. We need to check the left or right hand limit of function when x tends to x0. Now let's see what happens if the x tends to x0 from the right hand side. What value? What value of function when f tends to x0? x0 equals 0 from the right hand side. When f tends to 0 from the right hand side, it that means x tends to 0, x positive. X tends to 0, it that means the 1 over x tends to infinity. Positive infinity. Positive infinity is that means the exponent infinity is equal infinity. So we have the right hand limit of function when x tends to 0 is equal infinity. Okay? Right hand limit equal infinity. Okay, we return to third time. At least one or two limit here. You can say it belongs to infinite. Right hand limit is equal to infinite. So x0 we consider intrinsic. Essential difficulty. Essential difficulty because the right hand limit is equal to infinite. Okay? Infinite. Now, we consider example 3. Example 3. We have the function f, function y, defined by this formula. Here we have two formulas. This way on the x belongs to two parts of function, negative and positive. Now, we need to clarify the discontinuity of the function. Classify tức là phân loại các điểm đánh đoạn, phân loại các điểm đánh đoạn. In this example, we consider x0 it belongs to real number set. We need to check x0 it belongs to real number set. We need to find what x0 this continuous and continuous point of function. So first, we need to clarify x discontinuous and x continuous. To continue, if we know that x0 this continuity, we need to continue clarify the time x0. It belongs to first, second, and third time of this continuity. Okay? Clarify. Ở đây là trong cái ví dụ ban này là yêu cầu là phân loại các điểm đánh đoạn. Ở đây không phải là mỗi điểm x0 bằng 0, mà trong đây chúng ta phải tìm tất cả các điểm x0 là những điểm liên tục này và x0 là những điểm gián đoạn. Sau khi tìm được tất cả các điểm gián đoạn rồi, chúng ta tiếp tục xem x0 đó nó thuộc loại nào. Ok? Now, how to classify the discontinuities of function? So first of all, we need to know which x0 discontinuous point of function. Now, you see the function y is equal. The function y is equal x0 equals 0. x0 is not 0. The solution grade 1 x0 is not 0. Now, you can see the graph function. If the f less than 0, then we have the function has the formula y is equals 3x squared. Okay? When f greater than or equal to 0, we have the y is equal natural logarithm. Okay? At this point. If the x0 is not 0, what happens? x0. If x0 is belongs to here, you can see. What do you think about x0? Continuous or discontinuous point function?
Continuous.
How to check?
It's still defined.
What do you think about x0? It's like the left hand side. What do you think?
It's continuous.
Well defined?
Yes.
Yes, well defined. The limit, the two-side limit of function when f tends to x0 is it? Yes, you can see when f tends to. The limit here is it? It is. The final, to check the value of function of x0 and limit is equal. Yes, you can see when f tends to x0. The limit on the way f4 at x0. The same if x0 is belong here. So if x0 is not 0, we have the function f continuous at x0. Okay? You can see? So in this case, from the graph of function, so we can imply the x0 is continuous point. Continuous point. Continuous point. To continue, page 2. x0 equals 0. Now, what do you think about this point? Continuous or discontinuous point? Why? You can see the both sides. The both sides of x0 equals 0. The function f has the two formula, different formula. So if you want to check the function here, continuous or discontinuous, we need to check the one side limit of function. Okay? We need to one side limit of function. Now first, what do you think about the 1 plus what value? 1 plus it passes to the right hand side function at x0 equals 0. Okay, amplify the right hand limit. Here it passes to the limit f tends to 1 plus. 1 plus is that mean f tends to 0 from the right hand side. Is that mean f tends to 0 at greater than or equal 0. Greater than or equal 0 is that mean we use the formula to estimate. Okay? We use. So the here it equals the limit f tends to 1 plus natural number is 1 plus 2x over 2x
X không cộng thì là 0,9 đúng không? Hay là
x
0,
is time 2. How do you know when x tends to 0? We have the first factor here is 10 to 1. The second factor 10 to 1. So the limit we need to find have the value 2. Value 2. Continue. We want to find the right hand limit. What's the right hand limit? Right hand limit. Okay, we continue to find the left hand limit. What value?
0.
What value? Left hand limit. It does mean we find the limit of function when x tends to 1 minus fx. 1 minus is that mean x tends to 0 from the left hand side. Is that mean x tends to 0 and less than 0. Okay? X less than 0. X less than 0 is that mean we use the 3x squared. So
So the limit here, if f goes to limit at 10 to 1 minus 3x squared, if f goes to f goes to Now, who can tell me the x0 equals 0 belong to what type? The first, sum is continuous. Point. Sum is continuity of function. You have x0 equals 0 is sum continuity of function. Okay, I think examine now for the solution. For the solution. Okay, I think take a break 5 minutes.